Welcome to this first installment of the IPAM Knowledge Bites video series. My name is Tim Rooney, Director of Product Management of Diamond IP, and the goal of this video series is to provide an overview of the key role IP address management plays within various leading networking and operations initiatives. In this video, we're going to talk about Secure Access Service Edge, or SASE. If we look back at the various trends and challenges networking and IT departments face over the last decade or so, we've seen an increase in digitalization, basically getting information from paper onto computers, digitizing that information, which ultimately is being leveraged to transform through digital transformation the way the business operates. So providing that access to that digital information through APIs, automating several steps in the process by reducing the human intervention that's required, which leads to efficiency gains and ultimately to a completely digital capable business. And of course, the cloud is helping to facilitate that with all of the resources that are provided through cloud resources readily available, whether it be compute, storage, artificial intelligence, various other applications and functions, and even cloud applications themselves, such as Office 365, for example. The work from anywhere type of motif within organizations allows people to work from home, work on the road, when we get back to traveling, I suppose. But it really leads to, in essence, more workers off the WAN than on the WAN. So you've got these users accessing your applications that are not sitting on your network and maybe not exactly the most secure. Now, we talked about networking evolution a little bit in our last presentation on SD-WAN. So we'll just review that quickly here. But to look at this SASE, it really is looking at an evolution not only in networking but also security, and we'll see how one kind of leads to the other. So if we look at our traditional network architecture, if you will, from the last 10 years, it's been kind of standard where you have a wide area network within an organization and the enterprise kind of manages that. Any access to the internet is highly guarded through a demilitarized zone, or DMZ, which provides firewalls, internet-facing services, closely guarded and monitored so that all inbound and outbound internet traffic can be controlled and monitored and any kind of issues abated. But unfortunately, with the evolution of cloud, you end up with cloud providers having various locations that perhaps are closer than the DMZ to a given user. So for example, in Site B, I might have a user that is located in Europe, and my DMZ might be in North America. And so to traverse that DMZ to get to a POP that might be in Europe is rather inefficient, shall we say. So you end up with that latency that is caused by the WAN backhaul through your network to the DMZ. So you've got the control and the monitoring that the DMZ provides, but you end up sacrificing the performance, among other things, with respect to the cloud interfacing. So as part of the networking evolution, we're seeing, particularly with software-defined WANs, SD-WAN, is that now you have the internet is ubiquitous. It's pretty much available anywhere. You don't have to just go through one portal to get there. But with each site on your enterprise network having this what's called internet breakout, you can have its own internet access directly from that site without having to traverse through the backhaul of the WAN network to get to the DMZ, whereas Site B in Europe can get to the cloud POP in Europe directly. So that obviously will reduce the latency and improve the performance of my cloud-based application that I'm trying to access. Of course, on the flip side of that, without the DMZ and with all these more prevalent internet access points, certainly security becomes a concern, because now you've got a lot more sites with internet access that may not have the same level of control and mechanisms to detect and monitor and defend against attacks as you would have had otherwise in a DMZ. So the vision of SASE, which is really fostered by Gartner, primarily developed in late 2019, is really following this evolution of networking and security. And by the virtue of the fact that you've got all these internet breakout points, users accessing cloud applications from wherever they happen to be, they're really proposing a zero trust security posture. So within the old days with the WAN and the DMZ, pretty much you trusted, it was more of a defensive mechanism. You trusted everyone within the WAN. Once they got onto the WAN, they were trusted. And it was really more defending against attacks coming in from the internet. With zero trust, you trust no one. Ergo the name. And so even on your WAN network, you need to authenticate. Maybe there's two-factor authentication, several forms of that, where you are then, based on your authentication credentials, able to access certain applications on a least privilege basis. So that's really kind of the crux of zero trust, which is part of the SASE Vision, which is really required because of that more prevalent internet access. But you want to also be able to apply those security and other networking policies across various access types. So whether it's your WAN, internet, 5G, etc., any type of access that you might be having from a different site and location, you want to provide that consistently, and also across different locations and for end users. All, of course, with ease of administration with a consolidated control plane. So like SD-WAN, the control plane separation from the data plane provides a centralized view of what's going on, so to speak, from a networking and security perspective, so that monitoring can be performed and actions taken as necessary. And that applies not only to networking, rerouting and things like that, but also threat detection for any type of security vulnerabilities. And also with respect to performance, being able to perform those security inspections as the data goes by without introducing a lot of latency. And also, of course, providing high availability through multiple access points, redundancy, backup routes, etc., and all through a simplified end user interface. So really, I authenticate to my cloud portal, and then from there, my permissions should be set. I don't have to log in 3 different times. And really the end goal here is to provide unified IT networking and security. So for the IT group managing all of this morphing of networking and thereby security architectures because of this evolution, these trends, is really to enable IT to better manage it and through a unified interface and platform, and really cloud-based is really how the Gartner portrays this. So the core capabilities that Gartner lays out, certainly building on SD-WAN and its capabilities to have multiple interfaces, route data accordingly based on the destination that the device is trying to get through, equipping that with secure web gateways, which can then be used to access web applications either in the cloud or outside, cloud access security broker to really handle those authentication credentials, for example, and be able to then broker connections to different applications based on the user authentication and permissions. Firewall as a service, being able to also monitor data, detect malware, control access, and so forth from a networking perspective. And then again, all with that zero trust networking approach for trusting no one until they've authenticated successfully. And then again, all this resides within a cloud platform within the Gartner proposed SASE architecture. So it's really dealing with how to get to access or applications in the cloud. And then one of the recommended capabilities, of course, is recursive DNS protection. So no matter where you are, being able to make sure that your DNS is going to be secure. And I'll kind of put this on the side here, kind of spanning the SD-WAN and the security and the cloud layers here. And we'll see why in just a moment. Now, DNS is a recommended capability, but I would argue that it's pretty core to really how the network operates. I mean, let's face it, DNS is really the first step in every IP connection. And then users and devices will access the internet beyond the bounds of SASE. So if I'm not logged into my cloud applications and maybe I'm not on my SD-WAN network, my location supported by SD-WAN, I may still access the network. And if I'm using an unsupported device, a bring your own device, BYOD type of device, I could be pretty much doing anything. So users will access the internet beyond the bounds of SASE. Inadequate DNS deployment can degrade cloud application performance. So really taking advantage of that internet breakout by having DNS at each internet breakout location really affords a optimal cloud application routing perspective to get you to that nearest cloud POP for the lowest latency. Now, lack of DNS security, because these users will access the internet and then bring them into the office using their devices, You want to be able to protect against forged DNS resolutions, perhaps redirecting users to falsified websites on the internet. Malware proliferation for devices that have been infected, using DNS to locate command and control centers to download additional malware or to get instructions on what to do next. Sensitive data exfiltration through DNS tunneling, so actually taking sensitive data and coding it within the DNS protocol and sending that to an attacker's destination for processing of that data. And so it makes you wonder, should it really be called Secure Access Service Edge with DNS, maybe SAST? To Gartner's credit, now they typically don't really cover the DDI space or really haven't taken a serious look at it in at least 5-6 years. But I can see, given my portrayal of it spanning the SD-WAN and the security and cloud layers, I will give them the benefit of the doubt that DNS really goes beyond the SASE architecture, unless you're 100% cloud-based, and we'll see why in just a moment. Now, in terms of IPAM requirements, we kind of step back from just DNS and look at the overall IP address management requirements for SASE. What are the implications on how you manage your IP space? Well, certainly, you want to be able to track and manage your subnets and your IP address assignments across your WAN, your SD-WAN, your cloud, private, public cloud, your remote sites, wherever users are accessing your network. You want to be able to track those IP allocations through discovery or through APIs, and you want to be able to identify users and devices, for example, when they initialize. So IPAM can help with that in terms of when you're using DHCP, being able to identify a device at least when it connects to your network to be helpful in forensics analysis later on. You want to be really deploy DNS within the SD-WAN to resolve on-net applications. So that means that any applications that you still have running on your enterprise network that you haven't deployed to the cloud, you'll still need to be able to resolve those for users to access. So you'll still need to have authoritative and recursive DNS accessible within your on-net and not in the cloud, so that those resolutions don't necessarily traverse that internet breakout connection. However, for those applications that you do want to access through cloud, such as Office 365, the local DNS at each internet breakout site is key to be able to provide that optimal application routing. You can also deploy DNS in the cloud itself. So if you've deployed applications, your own applications, not necessarily Office 365, but your own enterprise applications in the cloud, in AWS or Azure, for example, you'll need to be able to resolve them, and so you can deploy DNS in the cloud itself, on the network, etc., whichever way is appropriate for accessing or resolving those cloud application destinations. And you also want to make sure you facilitate edge security. So it's all about the secure access service edge. So the question is, where does the edge reside? Is the cloud edge the same as my SD-WAN edge? And thereby, that's why I kind of portrayed the DNS spanning both, because certainly having that internet access and not protecting the inbound from the internet that's not from the cloud is equally as important as protecting that data going into the cloud. So, and then also being able to, along the lines of SASE, saying provide single pass scanning, you also want to look at DNS traffic. So I think just looking at the single pass of a data stream is a great concept, and it decreases latency and can improve performance, hopefully. But really, if you're ignoring DNS data, you're really ignoring an opportunity to improve your security. So the whole defense in-depth security strategy is well proven and really advised approach to security, because the more you can look at what's going on in your network in the various forms, the better you can identify what is perhaps going on and what can be done to stop a possible attack. So if you can't catch it in the data stream, maybe you catch it on DNS and vice versa. It just gives you an extra eye on what's going on. So we view that as very important to be able to provide that single pass scanning through DNS tunneling detection, for example, to promote agile scaling of networking and security services. So scaling, agility, of course, with cloud, with SASE, very big requirements, and your IPAM system needs to go right hand in hand with that. Now, if we take a closer look at the DNS security for the internet breakout, so this local DNS, once again, affords query routing to the WAN for forwarding versus the internet. So again, for those on-net applications within your enterprise network that aren't on the cloud, you don't want to direct your DNS queries for those applications out to the WAN, out to the internet, for example, or out to the cloud because they reside in networks. So you need kind of that local DNS capability to not just forward everything out to the internet, but you want to be able to discriminate that. Keep the local queries on the network to resolve internally, again, unless you're 100% cloud and everything goes out to the cloud. But in the most case where you do have some applications on your network still, you'll be able to need to discriminate those queries rather and direct them appropriately. Local DNS also enables the optimal resolution if authoritative DNS is so configured. So you want to make sure that for those internal queries, you have authoritative DNS configured appropriately as well. And then local DNS can also add a security layer for added protection to internet breakout sites, such as detecting malware through a DNS firewall, for example, to be able to detect queries to command and control centers, being able to detect DNS tunneling in line during the DNS query and answer process, and also to shut down those tunnels, validating the DNS answer authentication and integrity with DNSSEC, and then be able to mitigate denial of service attacks through rate limiting, inbound and outbound, and also tracing of queries and responses for reporting, auditing, and forensics. So very important aspect as well, to be able to go back and look at and analyze various historical events. And then controlling access to DNS functions through access control lists, which are somewhat more frowned upon with SASE because you don't want to be basing it on IP addresses per se, but certainly within the realm of private public address space and various allocations of your address space and reverse path forwarding prevention, you can also lock down IP-based access control lists. There'll just be less dependency on it with zero trust, but again, another layer that can improve your overall security posture. And then Diamond IP, of course, offers several deployment options for this so-called software-defined IPAM that applies not only to SD-WAN, but also to a SASE-type environment. So if we kind of look at that deployment configuration, so for Diamond IP, and we'll kind of break this down like SASE to network and security. So from a network perspective, providing a overall pan-cloud IPAM, in other words, looking across maybe your private clouds with VMware and Hyper-V, whatever you might be using in-house, KVM, and also public clouds with AWS, Azure, other public clouds you might be using, Oracle, and also non-cloud. So being able to provide a single pane of glass perspective on your IP address space, your DHCP, your DNS, across that entire environment, and also being able to touch base on that inventory or that view such that it's representing reality in terms of doing discovery from your subnets on network, those in the cloud through APIs, and being able to import that data so that your IPAM database reflects what's actually deployed in the network. And recursive DNS, certainly we have the ability to deploy that in non-cloud, private cloud, and public cloud environments. So we support a variety of virtualization technologies for private and public cloud, and you can configure those across your various platforms. And also we support DNS query forwarding, of course, so again, you can route internet-based queries and cloud-based out to the cloud and out to the internet breakout, whereas keeping on-network queries on your network. And then also, of course, authoritative DNS, so for internal destinations, for on-net applications, for your external internet-facing presence, which really isn't addressed at all in SASE. But being able to configure and deploy all that through the various platforms is, of course, supported with Diamond IP as well. Looking at the second aspect of SASE, the secure access, being able to configure DNS firewalls. Again, on all these platforms, all these services are available. The DNS tunneling detection and shutdown, in and outbound rate limiting, transaction reporting and auditing, particularly with our IPAM Auditor appliance, which provides a centralized perspective across all of your DNS servers as well as IPAM data. MIBs and traps, just from a monitoring perspective as well. Anycast addressing, just to provide a additional denial of service mitigation. And also, of course, the hardened operating system kernels, access control list, security posture of the appliance-based approach. So for the appliance platforms that we support on private and public cloud, that it applies. However, on the Docker image that we do support for private and public cloud, that is more of a service only as opposed to an appliance configuration, so it doesn't necessarily provide all of these security functions, but it's also free. So it's kind of the trade-off there. But if you want the added security functionality that we provide with our appliance, that's really the way to go there. And then to wrap it all together, certainly we offer the managed services option, which again, you can deploy, you can have your DNS deployed on your premise, in private clouds, in public clouds. If you're using our appliances, they can be deployed anywhere, and we can help you manage that, keep an eye on the appliance's status, and help with troubleshooting, also even making IP address management moves, adds, and changes. So Diamond IP offers a rich set of deployment options and capabilities to help you manage your eventual migration to SASE, which Gartner really portrays as seeing not until about mid-decade in 2025. That's when they envision really a vendor, at least one vendor, having a comprehensive SASE offering. So you've got some time to do some planning. In the meantime, Diamond IP can help you support the path to get to that spot.